Okay, we're going to go ahead and get started on our first tests here for testing for divergence, convergence, all that fun stuff here. So we're going to learn about the geometric series, nth term test for divergence, and the telescoping series here. So essentially, we're talking about series. Series is when you take each term of something and you keep adding them over and over again. And we use this sigma notation to note that. Okay, so like if I were to have like 1 plus 2 plus 3 plus 4, blah, 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 blah. Let's say that I keep going on forever and ever until I get to infinity. That would be the summation starting at n equals 1 or 0, just depending on what the actual series is. I'll just say 1 for this one. Of n equals this. Okay, so that's what series is. You're just adding those terms over and over and over and over again. Okay, so let's first talk about the geometric series test. So geometric series is in the form. So this is what a geometric series looks like. Again, it has that R term. If R is greater or equal to 1, then it diverges. If it is less than 1, it converges, and we can actually find the sum, which is kind of rare for some of these series. Is we're really not able to find the sum for most of them, but we can find the sum for a geometric, and this is something that you have done previously in pre-calculus. Okay, so we're going to determine whether the following series converges or diverges here. Okay, so this one, I can actually do a little bit of a rewrite here so that this looks like, because that 3 doesn't have anything to the power on it. This is really 3 times 1/2 to the n. Okay? So because of that, this is going to converge. So this is going to converge. You have to state why. By the geometric series test. And why does it converge? Because R is equal to 1/2. Okay, so this converges by the geometric series test. This one right here, well, R is 3/2. It is a geometric series because it's a ratio that keeps increasing or decreasing. So this one is going to diverge by the geometric series test. I'll just put geo series test. You don't want to shorthand write these too much because if the grader has no clue what you're calling it, like people like to put like GST. I don't know what GST is. Grader's not going to know that. So just put enough. Geo series test, that's accepted. So you'll be fine there. So that's a geometric series test. If you see a series is a geometric, you just find out the R value and then just go from there. Telescoping is like a very specific type of test that you might see. So a series such as 1 minus 1/2 plus 1/2 minus 1/3 plus 1/3 minus 1/4. What ends up happening here is these terms right here cancel out. The 1/2s cancel out, the 1/3s cancel out, the 1/4s will eventually cancel out. And then it's going to go ahead and converge here. So if you notice that something is telescoping and you can say, hey, it's telescoping, then you can actually use the telescoping series test. And what's going to end up happening here is we're going to get the sum of it will be just the front number. All right, so here's an example. And what you can do here to discover that it's telescoping is just to plug in the numbers. Okay, so like if I were to plug in like a 1, because that's the first thing you'd plug in, you would get 1/3 minus 1/5. That's the first. And then plug in a 2, you would get 1/5 minus 1/7 plus 1/7 minus 1/9, and it keeps going on and on and on like that. Okay, so this is telescoping because these terms are going to end up canceling out all the way through infinity. So what this is going to end up giving me here is this is going to end up converging by the telescoping series test. So this one is going to converge by telescoping series test. Okay. And again, the sum for this, everything's just going to cancel out. If you were to go ahead and find the limit of this all the way out to infinity of this series, so it'd be the 1/3 would stay, and then eventually we'd keep going until we get to this 1/2n plus 3. So this is like the infinite term because the 1/3 stays, that cancels, it's going to keep going over and over and over again. till we get such a tiny number out to infinity that, you know, this is 1/3 minus 0. So this will end up equaling 1/3. So this is the partial sum. Okay. So there are your two tests. Geometric series test, if you just recognize it's a geometric series, then you can just state whether it converges, diverges. State what the R value is, though. So that's really your work that you have to show here. For telescoping, you have to write it out as a telescoping, and then you can figure it out. You always don't have to find a partial sum. I just did for giggles here. One little note I do want to make here is I do want to talk about the situation where n equals 1 here for geometric series. If R equals 1. So if R is equal to 1, then it's going to keep increasing every single time. So that's why it diverges if R is equal to 1. Because actually, if R is equal to 1, it really is no longer geometric. It turns into arithmetic. In every arithmetic series, it all diverges. So just a quick little fun note on that one. One little note here, too. I'm just going to kind of just write out an example. Sometimes you're given problems with telescoping. Like this one was pretty easy to plug in and to figure it out. Sometimes for telescoping, it gets a little weird and tough because you'll get something like this. And this is actually telescoping, and you would have no clue. You would have to use partial fractions on this to figure out that this one is telescoping. So I'll kind of leave you to do that one on your own. So you just do partial fractions, then you can figure out that it is telescoping. So that is kind of where telescoping can be a little bit on the tricky side. Otherwise, it's pretty straightforward, just plugging stuff in. Okay. And then now let's talk about the nth term for divergence. So all of it's saying that if the limit does not equal 0, then a series is going to diverge. So we can only use this to tell if something actually diverges. So it's going to end up happening in this unit, because this is our third test here, is you're literally just going to be given some type of sequence like this one right here. And it's going to say, does it converge or diverge? And right now we only know we're going to know 3 in our repertoire here for what we can do to solve for this. Eventually we're going to get out to about, I think it's 9 different tests, 9, 10, 11 tests, like something kind of break up into little sub-tests. But anyhow, you have to figure out which test to do. So the nth term test is usually like the first test I always do. And you can just do it mentally if you need to, but it doesn't say if it converges. It only says if it diverges. So essentially, if the limit does not equal 0, then it diverges. Conversely, if you say that the limit does equal 0, that actually doesn't tell us anything. It doesn't give us enough information, FYI. So we can only tell if it diverges from the nth term test. So if I'm looking at this series right here, I'm just looking at it. It does not look like it's geometric. It's not telescoping because we're not going to have 2 different. We can't split this up into 2 different fractions. So let's just go ahead and find the limit as n approaches infinity of this test. Okay. So if I find the limit of this, since it's going out to infinity, the bottom one's actually going to grow a little bit faster here because I'm going to end up getting, top and bottom, they grow at the same rate. So what I mean by is we have a larger value on the bottom, the 3n. So just use the coefficients here, and you're going to get 2/3. So therefore, the series diverges. You always have to state the test by nth term test. So this diverges by nth term test. Okay, we're going to start to see factorials. They're going to become part of something that you just need to get used to with factorials. So the only test I know right now is the nth term test because it's not going to be telescoping and it's not geometric because there's no R value. So use the nth term test here. All right, so kind of sort of like this one. See how this is growing the same rate at the top and the bottom, and I end up getting 2/3. This is actually growing at the same rate at the top and bottom here. Okay, so over here, just have n's growing the same rate, top and bottom. So we just use the coefficients. Same thing here. We're just going to end up using the coefficients. So this is going to end up equaling 1/2. I will show you the work behind it. If you do multiply this by 1 over the highest rate, you're multiplying on top and bottom. That will take care of this, because that's going to end up giving me the limits as n approaches infinity of n factorial over n factorial all over 2n factorial divided by n factorial plus 1 over n factorial. And then the 1 over n factorial is going to equal 0. So I'm going to be left with the limit as n approaches infinity of top is 1, the bottom one is 2 plus 0, which is going to give me 1/2. So this one is going to diverge. So this diverges by the nth term test. Okay. Last one here. Again, look at the rates of growth here. It's growing the same as it is the top and the bottom. So because of that, my limit will end up equaling the coefficients, which is actually going to be 1. So rates are the same, top and bottom. I'll just show you the work here in green. So 1 over 3 to the n, 1 over 3 to the n. I'm going to end up getting the limit as n approaches infinity of 3 to the n over 3 to the n minus 2 over 3 to the n all over 3 to the n divided by 3 to the n. So this is going to give me 1 minus 3 to the n grows faster, so this is going to turn into a 0 all over 1, which is 1. So therefore, this is going to diverge, if I can spell diverge correctly. So we're going to diverges by the nth term test. So really, to sum up everything that we're doing here is we're trying to figure out if these series converge or diverge. We only know 3 at this moment. We know the geometric one. So if you can just look at it and see that it is geometric, then you can know if it diverges or converges. Or if we see that it is telescoping, which looks like this. All right, so here's the written out version. Here's the version that's in the summation. And then here's a version where you have to use partial fractions to figure it out. And that's only when you're actually multiplying on the bottom here. So if you can like factor it and have factors multiplying on the bottom, there's a good chance that it's going to be telescoping because you just got to use partial fractions. And then you can figure out that it's telescoping. Because if you just plug in the one value, like the values here, the telescoping portion of it's going to be like hidden. So you have to make this into partial fractions. And the last test we just learned here was the nth term test. You just got to take the limit of it. If it's not 0, then it's going to diverge. And a lot of that you can just do mentally in your head, especially as we start going forward, learning more and more tests. And that's going to wrap everything up.